Huskies, welcome to the last video of our domain and range series. And this is, can you find the domain and range of a function? Now, for A and B, we're going to state the domain and range. Part C, just the domain. Okay, so really important. Most of the time when we talk about quadratic, when we talk about quad, linear, cubic, quartic functions, the domains are all real numbers. We get into trouble when we start dealing with fractions. And number one, your denominator can't be 0. And then if you deal like in part B and C, if you start to have square roots, numbers under square roots, they have to be positive. You can't have the square root of a negative number. It's an imaginary number. So the two times when we start to have breaks in our domain and range is when we start to think about fractions and think about square roots. Then we have to pull the brakes on and say, whoa, 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 wait a minute. Let's see what we're dealing with here. Okay. So if we look at g of x, that's 1 over x squared. That is a fraction. We know that x minus 2 can't be 0. So if we solve that equation, x is 2. Right? So x can't be 2 here. Now, if you plug 2 in, or a number really close to that, so if you plugged in 3, you would get 1. If you plugged in 0.5, right, you're going to get that value close to 0, and we'll show you that in class. So y is not going to be able to equal 0 here, and you can confirm that graphically, because if you plug in 2, you would get, if you try to plug in 2, you can't get to 0, right? You can't have 0 for x, or excuse me, you can have 0 for x, but the output can't be 0, right? There's no value you can plug in for x that makes the whole thing 0. Your first guess would be 2, but 2 is not defined. So the domain of G, okay, is all reals except, so you could say all reals, where x cannot be 2. The range of G, you could say, is all reals except, in this case, g of x cannot equal 0. And there is your domain and range of that function. Now, in the next one down, you have a square root. If you can look and you say the denominator can't be 0, and you have to be greater than 0, right? Okay, your square root has to be greater than 0, that number. So x minus 4 has to be greater than 0. And it also can't be 0, right? So if we solve this, x has to be greater than 4. Okay, if you plug in 3 minus 4 is negative. Doesn't work because you can't take a negative square root. If you plug in 4, you get 0. Yes, the square root of 0 exists. It's 0, but you cannot have 0 in your denominator. So your domain is already written for you. There you go. X has to be greater than 4. So there's the domain of f, right? So if I wrote domain of f, x has to be greater than 4. So there's inequality notation, right? Or algebraic notation. Your range of f, okay, the range of f is also going to be y is greater than 0. Number one, the range is going to be positive because the numerator is always 1, so that's a positive number. The denominator can't be negative because of the square root, so you're always going to have a positive number, right? So it's like, what's the smallest number I can think of that doesn't go into the negatives? It's 0, but 0 is not positive or negative, okay? So we have to have values that are greater than 0 because of that square root. So you can't include 0 there because number one, you'd have a negative number. So your range is going to be the outputs y is greater than 0. The last one, very similar. You have square root, and so you're going to have 4 minus x squared has to be greater than 0. If we solve this equation, you have 4 is greater than x squared. So x is less than plus or minus 2. Okay, and so our domain is actually going to be all the x values between -2 and 2, when you can't include those values because you'd have 0 in the denominator. So that is finding the domain and range from a graph, if you have, or from an equation, excuse me. So if you have any questions, please let me know and just type them below. We'll see you next time.